using paper folding, it is possible, using what's called axiom 6, to solve cubic equations. And the way this works is I have this cubic equation, and on my grid, if we call the coefficient, we'll call A is the coefficient of the x squared, B is the coefficient of the x, and C is the coefficient, is the constant. We'll always make a 1. If it's not 1, we can divide through to make it a 1. So we have these three numbers, 4, 5, and 6. And what we do is we plot the points A, comma 1, which in this case is 4, comma 1, which is over here. We also plot the point C, comma B, which in this case is 5, comma 6, which is over here. We also create the line y equals -1, which is down here. And we also create the vertical line x equals -c, which in this case is -6, which is all the way over here. So now we want to make a single fold that simultaneously puts this point here onto the horizontal line, and puts this point here onto that vertical line. Axiom 6 says that it's possible to do this, although actually doing it is kind of hard. There's a bit of a trick for at least figuring out where the fold might be, and the way that works is if I kind of approximately make the two parabolas that have the points, this point wants to go into this line, so I make a kind of parabola. It's not really clear how wide to make the parabola, but at least approximately it looks something like that. Whereas for this other one, the directrix is vertical, so my parabola, and since these points are so far away, it would be kind of a wide parabola. So I'm just going to, and what this does, the folds is going to be the fold that's sort of the common tangent to the two lines. It ends up being something like that. So if I do this fold, notice how this point ends up kind of over there, and this point here ends up kind of way down there. Well, the slope of this, so the answer, the fold in a sense is the answer to the question, but how do I turn that into like a line segment that's the answer to the original question? Well, the answer is that the slope of the fold is the solution to the cubic. And the way we can figure out what that is we take a point on the fold and we go to the right 1 unit and then go down. This line segment right here will be the answer. And how big that is in this case, I didn't draw it so accurately, but that's still the answer. You know, maybe it's around 2 or something like that. So that's how. Now, I'm not going into why this works, just what the process is for doing it. We did learn in class things about slopes of tangent lines and how they're related, but this is actually pretty tricky because you got the two parabolas, and it's pretty complicated. So for now, this is just how you do it.